we're able to use our panelists and our speakers to answer your questions.
I guess my question was, you had mentioned before that it wouldn't be the military in domestic, but I thought that at times they'd scramble fighters if a plane looked like it was, potentially threatening, like when Payne Stewart's plane was flying solo, I thought they scrambled jets. I was just curious. I thought that the military in certain instances could do that. I could be wrong, but I thought they did that domestically at times.
So typically, I got the mic on here. So typically the response to an internal threat is executed through the National Guard, not Title X authority of our normal military. So in theory, through governors, through law enforcement authority of the governors, that is all a potential capability, although DHS has taken primary control of responsibility for that. How that balances day in and day out, I don't have the details of it, but when we have dealt with these issues before, and another classic one that I am a little more familiar with was cyber attack. I ran the operations center that responded to and then also coordinated offensive operations around the globe. And what we would do is I'd have sitting with me a commander under the National Guard Authority. He'd reach out through his network of governors to go to state police, local police to deal with individuals and threats that we had internal to the United States. So a lot of those things are established. With the UAVs, we're still not there, although, like I had mentioned, DHS has some authorities, Secret Service has authorities, and I believe some portion or some individuals within the FBI have been given that authority currently. What's ultimately necessary is a change to our federal code. The way Congress is today, I'm not sure we're ever going to get there. But those federal code that is preventing a lot of this stuff was put in place for a very good reason. Privacy issues, so just changing them for UAVs is not going to necessarily be as simple as we would all hope them to be. But ultimately, that is what it's going to take. They're going to have to make modifications, adjustments to particularly Title 18. If you want to look at that code, that's where it is.
I don't want to hog the question if someone else has one.
We have a microphone going around, so if you have a question, just raise your hand.
Sure, I'm Jim Frazier. I'm the VP of Smart Cities here at ARC. Our practice is deeply involved in autonomous vehicles. So at some point, can I surmise and intuit that these will be autonomous flying vehicles?
I suppose that I can make...
Next question.
Yeah. Yes was the answer to the first one.
All right, who's next?
I mean, you saw in Lux's chart there, the sequential chart of all of the FAA regulations. The top right one was autonomous passenger vehicles, I think, right?
Yeah. Basically commercial travel, scheduled travel.
So we're still quite a ways away, but I'll tell you what, you look at Uber and the amount of work they're doing, and they're connected to NASA on the UTM, which is unmanned traffic management systems. They are most likely be using a system called ADS-B, all right, which is, I can't remember exactly the acronym, but basically every unmanned vehicle will be constantly broadcasting its current identity, its current position and velocity, and communicating that to all adjacent aircraft. That will be done using GPS coordinate systems, and that's absolutely essential for autonomy. No pilots involved.
Yes, my name is Tim Sweeney. I'm with Jobs Ohio, state economic development for the state of Ohio. And certainly OSU is playing a role supporting Assure and Sinclair Community College in national pilot training. Certainly co-location next to Wright-Patterson Air Base, and then we have actually UAS test range in Springfield, Ohio, that is actually connected 3 radars for flying drones. And so that the data that has been collected and is going into the FAA for review. So we understand that. One thing that we are, from a state perspective, is looking at our strategy. We've got several lanes that we're focused on, but I would be interested in seeing the FAA's strategic plan, if that's available. That I don't know if it's online or what, but we have, from a state perspective, and I know other states are certainly engaged in this, is we've connected Fly Ohio with Drive Ohio, because autonomy is on the ground, it's also in the air. And so that's some of the initiatives at the state level that we're focused on. We want to make sure we're in sync with the FAA's plans and regulatory.
So as Ohio State reached out to win some of the internal projects that you were doing, we were involved with that at Assure because we're co-located. So Jim Gregory out of Ohio State can help out a lot in that regard. And one thing I do want to bring out, really 2 things. I have recently met with the Department of Transportation, and a lot of the challenges are intermodal. It doesn't matter if you're in the air or on the ground. Although in the air you have a third dimension that you can use for deconfliction and such. But there's huge challenges, and it really comes down to mostly data, and where the profit and margin and everything it revolves is in the sensors and the data. So that is the challenges, and what we're trying to do now is fire up Department of Transportation, not just the FAA, to now start looking at things like automation. How do you certify automation, which has been done in the military for very, very long periods of time. But AI, which scares the death out of everybody because it's non-deterministic. And we're working methodologies and concepts that go beyond engineering, and you give a machine a check ride or something equivalent to what you would do to a human being with tighter standards. So a lot going on in this space. A lot of help is needed, and ultimately it's not just the universities. It's places like Bentley and the operators out there flying that need to collect the experiences and how to better do the analytics, because I learned something, at least one, if not 10 things every single day, and how these capabilities are changing and how we can apply it to regulation to free things up versus restrict.
So actually, I want to interject a question here. Jake really showed us some very awesome 3D models. Those are really increased in their resolution and ability to be displayed. But this actually is a question for our panelist, Anne Marie. Could you tell us how your product deals with photographs, ultraviolet photographs, infrared photographs, LiDAR, and what is a GIS system?
So to start with, to explain a little bit about what Jake showed, we have technology that combines the photographs into a 3D reality mesh, we call it, and then produces a 3D model. What it does is look for an overlap between the photographs and pick out the pixel points that are common, and then joins those up and then creates a surface area, pastes the photograph back on the top. That's how. So it's a simple form of photogrammetry, basically, and that produces the 3D model. When you add the technology that we have today, where through GPS, which is, exactly the pin where that photograph was taken. These days, every time you take a photograph, you know precisely where it is. You can then place that 3D model on the Earth, which is, in effect, that's kind of the GIS, if you like, as I would put it. We find that the photogrammetry is only as good as the photographs you've got. Okay, but there's nothing to stop you, and this is what a lot of our users are now doing, is adding to that reality mesh and that model other information. So picking up you can the drones these days not only can carry a camera, they can carry an infrared sensor, they can carry quite heavy payloads or lots of things. So at the same time they're taking photographs, they're doing infrared scanning. So you can combine the infrared scan on top of the reality mesh and show where the hot spots, or as in the case of solar panels, where the cold spots are, for example, that kind of thing. And then if especially for the laser scanning side of things, and a lot of people are very used to laser scanning, and all laser scanning is also a point cloud, a point mesh. So you can add the point cloud to this technology as well. And what laser scanning gives is that laser scanning enables very precise measurements for it. So you would add the laser scan point cloud data to the reality mesh for those areas where you need pinpoint accuracy. Does that make sense? So and we actually, a little example we had. We also, when drones work, or photography from drones works really well on a good, nice, clear day. I wouldn't want to ask Jake some of his lessons learned. I think that would be interesting. So on a nice, clear day, if you've got fog, drizzle, that kind of thing, it can really distort things. So we did a test of capturing we needed to capture a piece of road, a 1.5 mile stretch of road in a really short time frame, process the model to produce it. It was not a very good day, so we ran a LiDAR car, a car with a laser scan on the car and the drone, and combined the two to create a much better reality model, which we needed to do on a certain day at a certain time to produce the model. So does that help?
It certainly does, and I guess then I would get a follow-up for Jake.
Yeah, lessons.
How is it that you could, let's say, screw up the data collection? Did you fly too fast? Did you take too far photos? Do you have to have enough overlap to your photos? I mean, do you have a specific high-res camera that you must kind of use? Obviously, the fog, I can understand.
Well, the weather in Pittsburgh is always beautiful. I mean, it's never an issue at all. But there's a million ways you can screw it up. Only one thing has to go wrong for it to kind of fall apart. It needs to have all the elements that you said. Depending on what the standard is for the customer, there's usually an accuracy standard that we have to meet. And even if there's not enough light, you can say, okay, well, I'll slow down my shutter. Well, yeah, you also slowed down your collection time by doing that. Well, and you can introduce some extra sensitivity to your sensor in the form of ISO, and if you push that too much, then you're for the photographers amongst us, you introduce noise, and the software sees noise as artifacts. It thinks that they're things, but they're not, and they're not consistent from one picture to another. So too much ISO can blow it apart. So this is why that my business model is relevant. Because there's a million things that can go wrong. Best practices have to be followed, or you're not going to get the kind of data.
Do you have typically automatic flight plans and then automatic control of the camera gimbal and pointing direction and shutter speed? Do you do that dynamically? Do you set that all up at the beginning of the flight, press go, and the drone goes up and down the space automatically? Or is there two-man operation, one on the camera, one on the pilot?
Safety compliance is one of the factors you have to consider there. For most operations to be deemed safe, it's a pilot and a visual observer. And to answer your question about the autonomy, semi-autonomous, for reasons that Lux discussed, is a requirement for the immediate future. We can have several different changes just on a cloudy day, where the camera will compensate for some of it, but you don't want to let the camera make too many adjustments because you need consistency in your data sets. So we are, we add there's some autonomy. We let the camera change a few parameters that we know aren't going to affect the output of the mesh, but we make manual changes accordingly, just to make sure that the camera's not making unnecessary changes. So it's not really a yes or no answer. We automate it as much as we can, with number one, the safety in mind, and number two, the quality of the end product in mind.
Oh, great answer. Thanks.
Colton Bond of Savannah River Nuclear Solutions, but this question comes as a drone hobbyist and an aircraft enthusiast. Has there been any consideration as far as keeping track of these drones, of using the current ATC transponder system and assigning a designated code for UAVs?
I think that Lux might be the best. Oh, no, go ahead, Jake.
It's definitely you, but I want to add a second part to that question. And I want to know if the universal traffic, what he had mentioned, or ADSB, or whatever the universal traffic management system that they are proposing has legs. If you think that there is a short-term solution to that, and a third part of the question, you remembering all this, is that if the answer is no, then does the no GA under 2K movement have legs?
So I'll answer the last first. Is I don't know, because it hasn't. That has not actually gotten into any levels of rulemaking within the FAA that I've seen. So I don't think that has real legs.
I didn't mean to hijack your question.
So in your question is the FAA formed a committee, mainly of industry, to give them a best solution for what you're discussing. Really is EID. For the various aircraft, because when the operations over people was going to come out 2 years ago, was approved as what showed up, the FBI and Secret Service said absolutely not. We want to know, is it friend or foe as a minimum. So out of this committee, they there's a notice that has come out that I haven't personally read yet of what is the methodology that they're going to do. One methodology is ADSB, another was some other form of EID. The bottom line is that's what they're going to. There's going to be an EID requirement that identifies that system, that vehicle, to some operator who's the owner, maybe not flying it, but is that owner, and it can be held accountable for that system. Because that, for the FAA, just think about everything they do as a hobbyist or an aviator, it comes down to almost always they want accountability. So a pilot in command, if there's maintenance required, who's the sign-off authority? So A&P mechanic, for larger type aircraft and things like that. So it is going that way. ADSB is interesting. It's a great solution because it's required anyway to 2020. But MITRE did a test that has been actually it needs to be relooked at again because they didn't necessarily do the best job on it. They said that UAVs would saturate ADSB. Now, if they just make a slight adjustment to ADSB power requirements, because you don't need to know for a UAV 30 miles away that it's there, and then as a UAV, you don't need to know about an aircraft 30 miles away. You just need enough power for your immediate vicinity for a minute or two. So those are all part of the solutions. The FAA hasn't determined its final solution. It's just sent out a notice of what it's thinking about for EID. Again, I don't have that answer of what that was because I'm agnostic. Whatever they do, we will have to do, and we'll move out on that. Does that answer your question? And did I answer your second and third questions?
Yeah.
Okay.
Thanks.
Chris Davis, VP of Smart Cities at SimCom. This is a business question. So looking at a very dynamic regulatory environment, Jake and others have presented some very interesting use cases. Has the market development for, let's say, a drone aerial solution company like Jake reached a tipping point where there's actually a viable business model and there are enough applications that somebody like you can make a really good living? And what is the competitive environment in your business? I'm just curious.
Well, I hope so. I hope that I think that there's a lot of people out there. We realize that we just had a conversation with a transmission and distribution company, or local to us, and they need our services because we live and breathe drone technology and data every single day. And they're just doing their research, and they're experts in their field. And they have really, they're at a loss for information as to developing their own program. And they should have their own drone program. But I think that in the coming years, there's going to be a lot of industry insight that we have from our experiences in our relationships with Bentley and the hardware manufacturers that folks that are developing their own programs can leverage. And I think that that's a big part of our model. And I think that there is going to be in the future people that are going to that are going to continue to outsource this type of thing because the technology turns around really fast. They don't want the expense. They don't want to have to constantly train their new people on, the brand new technology. And we think that until the industry is fully mature and all of the stuff that he shows up on his chart in the next 10 years comes to fruition, that the changes are going to be so rapid that a lot of the enterprise customers and stuff like that are going to be frustrated with something like that. They can't move as fast as we move. And that's kind of what I'm counting on there as a part of my business model.
It's interesting. You should know that Amazon applied for a patent on having a drone charging station on top of a street light. So we do street light controls, so we're going to meter that power that the drones use. And then we have an idea of using drones, and I want to talk to you, Jake, about this just to see if it's harebrained, which I think it is probably, but anyway.
It's my favorite kind of ideas.
But it was to use a drone to replace streetlight controllers. It's sort of a, like a dryer plug, 3 plugs, and it just goes in, twist and lock. You need to replace them, so if you could have a drone do it instead of a bucket truck, why not? 2 men in a truck versus an unmanned aerial vehicle.
So I'm going to chip in here because in the past 3 years that we've been talking about reality modelling which is this ability to create the 3D models from the photographs, the use cases have exploded, absolutely exploded. And we get each year our users submitting for the most innovative projects. And there's so many use cases, but one that I've been talking about a lot recently is the replacement of using drones to inspect telecoms towers, basically, just and not only go up one of the utility owners said it saves a young lad his knees going up and down the telecom tower because it's really dangerous and very hard on the legs, as it were. But now we've several companies like Jake's who are offering inspection services for telecoms towers to identify issues. So not only do they program the drone to fly and consistently capture a really good reality model, but they're beginning to automatically identify the assets on the control on the tower, the radar, the antennae, that sort of thing, and now using pattern recognition software on the reality model, which is something that we've been working with these users to do. So what do you do? It's not just a pretty picture anymore. You need to be able to automatically identify some issues, bring the attention to the inspector or to the person who has to do something about it, saying you have an issue here. So one of the research areas we've been doing with pattern recognition is automatically identifying rust. Now we're getting to automatically identifying how bad the rust is, not only just there's a patch of rust here, a patch of rust there, but actually, and really trying to bring attention to in the reality model to issues that the maintenance people have to look at, basically. And the telecoms towers all over the world are now being automatically inspected in this way by drones with this kind of technology. So, oh yeah, wind turbine, yeah.
One thing I do want to throw as an anecdote is in that disaster preparedness thing I was talking about, we started scoping this about a year and a half ago. And companies like Jake's, we went out to with the concept of if we created regional providers, service providers that could come in and if we train them, they could come into an area that's under disaster and support and clean it all up. That was kind of the business model. It had to significantly change in about 2 months ago when I went to actually kind of, again, scope it because Jake's company is too busy. He's got contracts. You know, where they were all hungry a year and a half ago, they're actually building business and it's expanding. And if the disaster occurs in Jake's area, yep, he's good, right? Everybody understands him helping out and getting things done. But that UAV company in Texas that I want to bring over to Pennsylvania may or may not be available based on, and that whole, how full they are now and their contract requirements is changed only over about the last 12 months.
I'd like to add a couple of comments to that, because certainly those companies that had taken the risk and, had maybe some expertise in certain areas and were early adopters, they now have the experience, and as was mentioned, Jake's company's busy. If you look at the CAGR, growth rates of drone industry for commerce and industry, it's way up there in the 20s of percent. The construction industry is higher than that. You also give you the comment that imagine you're a farmer and you see all your other farmers, saving money on their water, their fertilizer, and insect issues. You're probably not going to want to fly your own drone, buy your own license to Bentley, do your own data analysis. You really want to have a company come in and say, fertilize now, water here, this is how much you need to water, this is how much you need to fertilize, and this edge of your field has insect problems. And you want to be on your tractor fixing those problems and making money farming. So there's a huge market really for those people that have the expertise to just be able to come in and handle the whole project turnkey, flight planning, all the legal considerations, that understand all the rules and legal issues, and even you may not even want to have your own drone. I don't even know if you guys use your own drone or you're drone agnostic. The drone issue is not so much, it's the whole data handling that's really the expertise.
At least initially, they don't want to do that. When like I said, in 5 or 10 years, when they can go outside their house, press a button, and the drone flies up there, records the crop health, automatically communicates with the irrigation equipment, and and it's a completely hands-off approach. Well, yeah, there's no space for me there. But initially, the consultation is here for them to get familiar with the technology, at least to. If you let it advance too much and it gets too big, then that integration is going to be a lot more painful if people wait too long. We're already starting to see that the innovators have already cut the path, they've cut the trail, and now that, like you're saying, that a lot of it's playing catch up. Is the competitive advantage is already out there. But I wanted to double back to your question about the smart cities. There's a lot of what you say is a harebrained idea. But it starts with a conversation. I was discussing someone that was had a discussion with someone that was in security, just cameras. And he was working with a local government, and they have this system where if there's a gunshot that goes off, then they can triangulate that position, and it pings a GPS coordinate. So you have the GPS position of that. I mean, there could be one of these tethered type of drone in a box scenarios where they have that nurturing environment that's contained in a box, and that drone can be automatically programmed to open up and fly to that location. It knows what time it is, what sensor it needs to have active to say that it's infrared, and start, deliver a live feed to the authorities in the middle of the night over top of where that gunshot went off faster than anybody could ever respond to it. I get up in the middle of the night with this type of stuff, so we could probably. Okay.
Question up front.
Hi, I'm Julie Murdoch from Infor. Just curious if there's a customer or somebody out there, potential customer, who's interested in looking into drone technology, but they're not in ag or construction or someplace where they know from their peers kind of what to do. Is there a clearinghouse of information, any kind of site, anything, the industry Bible, or anything that would give up-to-date information versus going to the FAA site and to vendors and all of that? Is there any kind of clearinghouse?
Not to short ARC here. AUVSI is a treasure trove of unmanned system knowledge. I mean, they have databases, and so any specific area that you have any interest in, they're a really good source. Matter of fact, we use a lot of their databases and research to get us initially pointed into areas. I mean, that's their job, right? That's their sole focus, and they're international also, so they got a whole.
Building on the question of the convergence of Drive Ohio and Fly Ohio, I come from the transportation world where we have automation hitting vehicles. And we know that autonomous vehicles are still quite a ways out, but connected vehicles are very near term. And some vendors are actually in the market with a connected vehicle, and I won't bore everyone with all the details, but basically, you're not allowed to occupy somebody else's physical space. So that if you're converging on someone, your brakes will come on if you ignore the warning. Is there a scenario in the three-dimensional transportation space where that same very simple, very low-cost technology can be employed, where if I'm converging on somebody else's box, I'm not allowed to go there?
So initially, they've already defined what those spaces are, the boxes or the hockey puck is. There's technology and algorithms to avoid that have been kind of provided, vertical versus horizontal, and debates of which methodology is best and how to do that. So this work this summer will kind of be the end all, not the end all, at least the first step in defining the minimum performance standards to do just that. You got to be able to avoid the hockey puck, or even in situations, there's been some discussions that near misses are okay, just because the situation was so violent that we'll accept a near miss because that enables 3D use of airspace. So that work with a bunch of smart industry people, because they have a technology that they want to make sure that we don't regulate, make a suggestion, it's performance-based, so hopefully we don't hinder them. But if there's a unique capability that we need to see, or Wes Ryan, who's FAA certification guy, needs to see, and he can go to us and say, that's probably acceptable. Can you test around these areas and these edges? Let's do that. So that is where we are. That is right where we are over this next year. And then a marker will be placed in some form of regulation around that and certification requirements, and then we'll adjust from there.
Great.
I have another question for Jake, if I might.
Okay, go ahead. Sure.
In a practical sense, you're flying over an active construction site. We heard from many people, the interaction between the cranes and stuff like that. How do you practically get over the changes on the construction site in terms of cranes and heights to fly the patterns that you do, etc.? Do you use drones with sensors and they adjust it, or that kind of thing? What pragmatically do you do to avoid these collisions?
They have onboard systems, but we don't rely on those. If something goes wrong with the human input and we made a mistake, then we rely on the collision avoidance that's built into the drones. Mm-hmm. But there's an analysis, a documented step-by-step site analysis of the existing conditions. We know about how tall the cranes are from being there so much, but we go out and spot check. We take elevation tests of all the cranes that are even close to that space, and then we document that. and we communicate that between however many pilots that are flying the site at the same time. And then the grid is automatically adjusted, and if it goes beyond what we need for the accuracy requirement, then we take a little bit more of the manual data in between on a lower elevations to make sure that the product is there. But there's one of they call it the MOAC, the mother of all cranes. It's at the Cracker facility, and it's 770 feet tall. So we've developed it when they stood it up. We developed our automated flight path just goes around a box that is just beyond the range of the boom of that crane. So the automated flights navigate around it, and then we you use the visual observer after the automated flights are done to get in a little bit closer with very closely monitoring the where it is in relationship to the crane booms. But that's something that you have to do on on a regular basis. Every site has an analysis there. That's where it goes back to semi-autonomous is a requirement for the immediate future.
Thank you.
Good question.
So, quick question. So, in regards to using aircraft travel, if you have a multi-engine fixed-winged aircraft, you lose an engine, you can still operate off one engine. You lose both, you can glide in. Now, whenever I'm flying my quadcopters or hectocopters and I lose one engine, it immediately flips over to the ground. How far are we away from having the technology for the other rotors to compensate? Or is it there and I'm just buying too cheap of drones?
Yeah. What industry does depends. We have gone to testing of systems that are more than 4 rotors. Usually the 6 or 8 motor engines. We were able to identify. I just read the report last night, the cover report of all the reports. And one of the things they bring out in that was just that discussion. You lose one, you're okay. You lose 2 on axis, you're still okay for this particular drone. So what that'll bring up to the FAA is, okay, is there a part of our certification, even though this one's bigger, it is potentially safer because of just that. But now we add weight, so now you probably need a parachute. So there's these different mitigations, and until industry comes into a standardized solutions that are scalable, I believe in some time we're going to get systems that are designed to be the trucks for the particular concept of operation that you need. And that is one issue that I had not thought of. I mean, I'm a pilot, and I should have thought of that, but I just read that last night. And that's one of the solutions is, more better engines.
One of the drones that I showed up there, that white one with the tilting rotors that tilt into the direction of the wing, you notice that it must have had 20 different propellers on it. All right, and the way I understand it is that was in fact designed. The European Space Agency is kind of supervising some of the testing of that drone, but it was designed in such a way that the battery piping was going from some batteries to some motors in such a way that no single failure of a battery or a rotating propeller would be able to take that drone down. All right, any more questions for our panel of experts? I would also like to encourage you on your app to find our app and give us a rating on this session. All right, it's very simple. You find the app, and I think you press from 1 to 5 stars, and we appreciate that. You can find, if you need to contact any of us, you also can use that app to find each of these attendees. You can go to the session, if we forget our names, and find those names, and you can send us a message. And if not, just look up ARC, and we'll help you. I would like to have our panelists and speakers give a hand of some really expert people that we had here today.